you're going to make the presentation on week 16. We're going to reserve the time for each one of you. Going to make a. Basically, the presentation is about what do you learn and showcase your assignment, your project, right? And share your experience, good or bad, and yourself, right? Or I'll give you a template, right? 1 week before the presentation time. That means I probably will give you the presentation on a Monday, 11/27. So give you a template so you can fill in. Basically, 7-8 slides, right? And show what you're saying, right? Okay. Part 2. I think I already posted the requirement, the rubric, also the drawing set. In terms of working load, I expect it's going to be lighter, maybe 2/3 working load compared to your part 1, because it doesn't really have a lot of detail reading, plan reading part, right? I think you probably spend a lot of time do the plan reading especially if you're not good at it, right? So you could read all the rebar stuff, all the structural stuff, right? That's probably more time consuming than this one. But that doesn't mean you need to relax now. I prefer you right? Give you a heads up. Right? You start working on that, you can relax a little bit later, right? Okay. So today's topic, all right? You're gonna learn how to create a site, including contour, topo surface, and some of the sub-region, for example, different items on your site. For example, you have a sidewalk, right? And possibly you have some kind of a lake, water body, some kind of different landscaping part. Just think about a sub-region is like you have a different floor finish, right? Or wall finish, different color, different texture. The difference is now all your surface is actually, right, in a contour line instead of a flat, right? Right? It's all on the turn. That's kind of the concept of sub-region. Everything is very similar to your split face, right? Split face on your floor, carpet finish, right? Except this one is actually on the contour, right? On the contour. Don't get confused. There's a function called split surface. It's different from split face, right? Split surface only used in the side part, right? It is actually think about a sharp knife cutting through your birthday cake, right? And basically you split the whole cake instead of just the surface. But the name is a little bit misleading, right? So you can cut in through this one, so you have two separate 3D model, so you can edit independently, right? The opposite operation is called merge surface. So you glue them back, right? Glue them back. So it's opposite, right? This two operation is just opposite. A graded region is a very useful tool for contractor, especially if you had some experience to estimate cut and fill, earthwork moving, right? Cut and fill. So when you do the manual cut and fill estimate, you typically use what? Four corner method, right? I'm not sure if that's still part of your 3, 7, 8 still part of your class, and maybe it's kind of like, I'm not sure it is, eventually that should be the knowledge you learn or not, because Rivet can do that very easy, right? And you don't need to even know, right? All the stuff. So if you have some painful experience in the past, do the four corner method. Now you can forget about it, right?
In 241, we did that.
Oh, you did the 241, right? When you have a large area, that could be very time consuming, right?
Yeah.
So, I haven't talked about that. I think some side talk, right? Because I will consider this is I like to have the future time have a construction technology course. We're not going to talk about equipment stuff. Instead, some of the future technology going to affect us. Of course, BIM is a ongoing stuff, but a lot of things is go beyond BIM, right? And for example, a lot of new technology applied to construction, not only about the robot and also but artificial intelligence. So in the future time, I'm not even sure it's the future time, because a lot of the article you read currently published by the newspaper, by the magazine, by the online whatever media, they are not written by human. They're actually by software. A lot of them. And you see that something happened a minute ago, then there's an article about it, right? A lot of those are written by the software. So the software now can read stuff, can write stuff, and some of the paralegal stuff can be now replaced by software. And also, so I definitely think this is going to affect a lot of us. You think about your specification. Now they, several volume of this, right? And nobody really want to read that. Actually, I don't think you need to read it in the future time, because those are most likely be totally, read or write by machine. And you just ask the machine, okay, what about this? And they give you an answer. You really don't have to read it anymore. So because anything like a structure stuff will be replaced. If you don't underestimate those new technology, because it will be everywhere in our life. Not only those repetitive stuff, but also some of the creative activities. Even today, the composing software, and if you gave a genre of the software, say, okay, create something similar as Bach or Beethoven or some composer, right? The machine will create some music. Even the professional couldn't tell that's not human created. So they did some kind of test, asked a lot of those professionals to tell, okay, this is who actually created this piece. They were guessing, those different musicians, right? Those composers, and 50 of them won't doubt leadership by someone of those, famous computers. No one even think about this by machine, right? So that's a level of current, artificial intelligence can achieve today, not tomorrow. It's today, right? I think that the penetration of this technology to our industry will be faster, I think, than we can imagine, right? So I think we needed some kind of some course beyond this beam, right, to talk about, right, kind of have some better idea to prepare yourself. Okay, that's something, when I talk about the four corner stuff, a lot of things you probably don't even know anymore, right? And will become obsolete. All right. So that's the topic we plan to cover, and also you can see related to the content, right? And about terrain, straight sidewalk, and curb, right? Curb gutter and parking stuff, right? We're not going to talk about retaining wall because it's, I just crossed over, right? And topple surface is the first one we're going to learn, right? And by the two way you can create a contour like this, right? There's two ways you can do that. The first way, of course, you define the elevation of the key points. For example, and you can see the dot, the black dot is actually a point. For example, I define this is my 1,000 feet elevation. Click on this. Then I change that to 1,500. I click this. Then I click 2,000. This. Right. Afterward, the computer will create a contour. Right, and they will connect all the dots. So they created the contour. This is one way you do manually adding those stuff. The second way is import from other file, right? The civil engineer may give you a civil 3D file or AutoCAD file, specify, or they already got all the contour, right? So you simply just import the file into Revit, and the Revit will convert it into a Revit topple surface, right? Basically, if you have someone gave you the file, you don't have to do that anymore. So otherwise, you can simply do yourself. After you create those topple surface, right, or the contour, the next thing is you can create some of the subregion, and that subregion tell you a lot, right, by name, and because it is indeed a subregion, right, and it's, for example, can be different material texture, right? For example, in this area, I have a parking lot with asphalt, right? Or is a small pond or lake, or a special landscaping feature. So you can actually separate, divide the region into, as I said, a sub-region is very similar as you did for the split face on floor or wall, and the difference is they're on the flat surface. This one is actually in the terrain, right? The terrain. All right. Then there's a split topple surface. This is different from subregion, because so subregion, no matter how many subregions you created, they are still same contour body, right? But when you do the split top surface, is actually, like I said, like you use sharp knife cutting through your birthday cake, is actually created several separate body, right? Several separate body. So you can do editing of each body without affecting the other one, right? And you can see something like this, right? All right. This one, as I said, graded region and related to the earthwork takeoff. So how many of you participated this year's student competition in Nebraska City? Anyone in this class? No one? All right. I think if you, I think we win #1 in the heavy highway. That's quite good. but I'm not sure they ever use this, and to do earthwork takeoff. So basically, the theory is pretty simple, right? And the computer just want to know what's the existing, right? What's the existing terrain, and what's the new one, right? To compare the different, they gave you the cut and fill volume. So basically, you have to tell, okay, here's the existing, and here's the new, right? If we relate it back to your next project, you can see that's your, I think it's a grading plan, right? Yeah, site grading plan. What's exactly mean the site grading plan? Site grading plan is, show you how you grade this, right? How you're going to grade this. You see, typically have a existing. In this case, typically the dash line. Basically, all the existing line, right? That's your existing terrain, right? Then the designer will base what you design, right? Just like you design a building, right? You're going to design the grading, right? You can see the solid line. The solid line is a new terrain, right? You can see, right? Those are existing. It's pretty much what? It's 1173, and the new one looks like going to change to 1172, etc. Right? This one also going to relate it to one question you guys had in the last part one of your project. I remember you asked me, okay, should we put the level 1 as 0, 0, or should we put it as 100, right? So I said, well, if you don't want to have all the hassle to convert all the numbers, you just put, follow whatever they put on the drawing, right? You make your level 1 100 feet, make your top of the footing 85.4, right? Just, this way you don't have to calculate, right? Same thing for this one. The difference is, I think you need to do a little bit conversion this time, because you can see this one, architectural finish elevation 100, right? That's what we created a model last time, right? But the surveyor tell you that's equivalent to 1172.5 feet, right? So the 100 equivalent to 1175.5 feet in above sea level, right? Above sea level. So that means this is absolute elevation, this is relative, right? So when you draw your site, right? When you draw your site, so your, for example, that line, say 1172. When you draw that one, you're not going to specify the elevation of that line as 1172. Instead, you're going to do what? You can tell me. Should be relative. Should be 99.6, right? Because that one is half inch, half foot below, right? So that 1172. When you draw that, it should be, if you use the same elevation, that should be 99.6, right? Or you have to, if you want to use the 1172 this way, then you have to change everything else back to, you have to convert your 100 to 1172.5, right? I think you have to make sure they are consistent, right? Either you change your controller, then you always change your existing building elevation, right? So that's about the relative contour or absolute elevation, right? Okay. So afterward, the computer can figure out, okay, how much changed. Did they cut it? How much did they cut? How much of the film, right? Building pad is, to understand the building pad, if you take a look at this picture shows you a building pad like this. You may be wondering what's the difference between a building pad and a floor, right? If I draw a slab on grade, is that a building pad? Well, it's not, right? What's the major difference? Building pad, actually, you can think about is a void, right? Is a void with a solid bottom, which means if I specify the bottom of the building pad is -6, it will cutting into the earth with a void cutting into the earth. But if I specify the slab as a -6, it will be submerged into the earth. You see the difference? So that's why we need a building pad, even you have a floor, right? So the building pad itself don't have to be a slab, right? For example, if I already draw a slab grade on my basement, so my building pad bottom could be, I can specify as 6 inch of gravel and sand, right? So your building pad is actually a void with a bottom, with a solid bottom. This solid bottom you can specify at any material, right? Could be an insulation, rigid insulation, could be a vapor barrier, whatever, right? So that's about the building pad, right? Building pad is essentially, I want you to remember, is a void, right? It's a void cutting into earth. And then there's some easy part. You can see parking space. It's ADA, bike rack, pedestrian, trees, etc. Right? Those are the ones you just grab and use that on your site plan, right? On your site plan. And the property line is nothing special. If you still remember what you learned, right, in the past, one way you can draw that is just, draw the line, property line, right? That's as simple as that. And of course, there's another way you can do that is use so-called a bearing, right? When you draw that, you have in the past, you draw starting point 1, you have 15 degree northwest, then right, you go 60 feet, then you go the other way, right? They call that bearing, right? Distance and bearing. I don't think that's nowadays used too many. All right, let's see if there's anything here. Yes, you can see this, right? Kind of like, yeah, the property line here, right? They pretty much just tell you the distance, I think, distance. All right, let's give a couple examples in Revit. You can open your Revit 18. Right, start create an architectural project. All right, you may be wondering what's the difference between level 1 and the site, right? One noticeable difference is your site plan have a strange icon right in the middle. You may be wondering what's that. This actually 2 reference points. serving different purpose, right? You see, one is using a circle, another one uses a triangle. They're just on top of each other, right? But if I move my cursor close to the center, right, you can select any of this and move that one to the side. All right? Now they are not in the same position, right? So this one showing it as a project base point, right? With north, south, negative 24, east, west, negative 37. What that mean, right? Elevation, nothing. Angle to north, 0. Let's click on this one. This one is a survey point, right? The survey point have a, you see, north, south, 0, 0, east, west, 0, 0, everything is 0, 0, right? It seems you cannot change the number unless you click on this, right? Unless you say, okay, I want to change the number, then you can change the number, right? Typically, your survey point is absolute point, and your project base point is relatively to your survey point. See, if you drag this project base point further, you notice the number keep changing, right? Because this number showing its relative distance to your survey point. And by default, they are same point. But that's not always true, you know. And we call the project benchmark point is actually the survey point, right? So typically the survey, when you do the stake, right, here's the benchmark. The benchmark is actually this point. And you may have a separate project base point. Typically it is relative to like a building corner, right? Building corner, because it's easier to do the layout. But you have to know, right, the relative position relative to your benchmark point, right? So now we can see this is actually negative 40 represent this direction. You can think about it like X, Y, Z, right? X, Y, Z, right? Z is your elevation, X, Y is like this, right? This is actually north go this way, negative 40 is actually south of that point, 40 feet, right? This is actually going to be west of that, right? West of that point, 45. Basically, this is 40, this is 45, all right? Relative to that one. So if you want to also change the Z elevation, right, relative to the benchmark, so you can change the Z, right? For example, your benchmark don't have to be always the same as your project based one, right? Same level, don't have to be same level. So you can change that to negative or positive, right? By default, of course, right? You can, for example, the back, right? Now you can see they all become 0, right? They all become 0 because they are same point now, right? This is very important when you have some collaborative work, right? And for example, think about a project, different people doing the same thing, right? For example, one person do, and if you want to do a quick project, let's say you have 4 persons doing this project in parallel, right? One person just draw the architectural envelope, one person just draw the concrete and rebar, another person draw all the steel stuff, right? And maybe another person draw, site, etc., right? So you say, okay, you 4 work together. So eventually, how are you going to put your stuff together? What's the most reasonable way to put them together? Using the same reference point, right? Share the same reference point. So this way, when we put it together, you don't worry about, okay, your outline is this much, right? because if you use same reference system, you guarantee you will be in the same position, right? So that will be very useful. If you just do the opposite, then you have to make a lot of changes, right? And you okay, I have to move this part, X, Y, Z direction, to make the one line, right? So this, understand this one will be very useful when you do a collaborative work, right? Collaborative work. So basically you can acquire stuff. For example, person one, start a project, and person two can say, okay, even you give me your partial done file, I can acquire the same coordination set from your file, so we can work on my parts. So I can share that, right? You basically share the same reference point, right? Either by survey point or project-based point, right? Okay, let's start by drawing contour line, right? We talk about site, right? And if you click on massing on site, yeah, we did it one time, right? We did a place a mass. Remember, we did a glass curtain wall dome, right? When we did that, we insert from here, right? And we're going to talk about more mass next week. But this week, let's focus on, right, the site. When you click on the topo surface, basically is a terrain, right? Another way to say terrain. As I said, you have two ways you can create a terrain. One way is you place point from scratch. The second way is you do that you import from other file, right? Other file. So let's start with place point, right? You can specify elevation of this point. Let's use 0, 0 as starting point. So we click on this point is 0, 0. Nothing happened, right? Of course nothing happened because it's only one point, right? If we click on this one, nothing happened, right? But we know these 2 points share the same elevation, 0, 0. What about when we start click on third point, it's starting to create a surface, right? You learned that from your middle school geometry, right? 3 point determine a plane, right? 2 point determine a line, right? And 3 point determine a plane. Of course, you can continue to do another one, right? So we create a box. So this box actually, if you want to make it looks more formal, you can keep adding lines, so eventually you have a more square shape. So all those points so far we put on your plan is 0, 0 elevation, right? Let's raise the level to 10. And when we raise the level to 10, so this point will be 10 feet. All right? You see that? I said, okay, this is going to be 10 feet level. So you may notice the density of this contour line is different now, right? And of course, you can see some of those, right? More dense than other part. Of course, the more dense part is more steep, right? This is the more flat part, right? The flat part. So let's change that to 15. Let's find another one, 15. So if we put a 15 here, you can see continue change. Every point you added will change existing because the transition will be automatic, right? The transition actually automatic. Make sense? So let's just add the 3 at this moment. Well, if you want to dig a pit somewhere here, let's just dig a pit, right? So let's dig a pit using what? 2 maybe. Right. Let's use 2 to dig a pit. So if you want to dig a pit, use 2. So let's do that here, right? 1, 2, 3, 4. Right? So I dig a pit. Okay. And maybe even deeper, right? I can change that to -2. All right. So let's see down what it looks like. I don't know what it looks like, but okay, you can see it basically creates something, right? Something here. Yep. And if you turn to the bottom, you can see, right? And something. Did I just did a -2, but I didn't see much. You can, if you're not satisfied, you can go to edit. All right. You can do the edit surface. For example, I can continue to do, for example, -5. Right? If I want to say, okay, I want to do a big pit. So I can see use the shaded line to see. Right? Okay. So that's how you create a contour, right? How you create a contour. Yeah, I do see there's some terrain change, right? Okay. Afterward, let's do some editing job, right? Editing job. We talk about subregion. Let's do some kind of a subregion so we can see what happens, right? First of all, let's create a lake or pond, right? We go to subregion. Well, we want to create a pond over here. So or if you would like to, you can, let's see if we can use pick line to see how it works. I couldn't pick any line, so back to maybe just trace if you like to. Gotta be a enclosed area, so it gotta be, right? Say done. Right, I created one stuff. Let's assume on the top we have a grassland, right? So we can go to create another one, do another subregion, right? So I can pretty much do this. Oh, I can make sure what my trim the edge, make sure it's perfect. So this is my second subregion, right? Let's just, well, you can also, yeah, let's just do the 2, right? I think it's probably good enough. Now let's add a grass material to the top one. So we go to, click on that, then you go to material. You see that? So let's pick a material. Do we have grass? We can actually, let's do this. Let's duplicate air. Duplicate. And let's give a name called grass. I think by now you should have some familiarity, right? And this is our grass now, right? This grass, let's change the material, all right? We click on the graphic part, right? Then we use render appearance. Let's click on the appearance tab. Then, you know, appearance tab, there's, you can see there's a bidirectional arrowhead over here, right? And click on that. Then you go to site. Yeah, it seems it doesn't have enough grass for the first one. Let's go to second folder. Second folder, you go to sidewalk. Yeah, you have plenty. All right. You see you have dark Bermuda, you have light right, and so let's pick any of this you like to. Apply. Oh, what I didn't select that. Yep. Right, if you take a look at graphic, it looks like this shadow shade. Appearance, that should be, it looks like this, right? And say OK. Well, if your shade is on, make sure your shade is on, right? Shaded, that should looks like this, right? What about this small pond? Right, we go to small pond. Then we go do the same thing, right? I go to categories, you can see material. This time let's change this grass, duplicate that one, and we call that what? Water. Or you could call pond, whatever, right? So not only the name, let's change the material. You go to appearance again, then go to change the material. This time you go to second folder again. There shows something called liquid, right? Liquid, that's plenty of stuff. If you like the tropical blue or water bubble, whatever, right? That looks quite nice, right? See those? Right? In appearance, it should be looks like this. Say OK. Now you have a water body, right? And if you want to, in the 3D view, turn your shade on. Right? So let's look something, right? Okay. Now you know anything you like to, right? You can basically. One thing I want you to notice is the surface you created, right, doesn't change any of the terrain, right? Because it actually follow the terrain, not change the terrain. It's follow. So it follow the terrain. So it just changes the texture of the surface, right? Change the texture of surface. So let's do a, yeah, we got this part done. We got this part done, right? Let's do a split surface. As I said, if you split a surface, actually, you actually like cutting, use a sharp knife cutting through your birthday cake, right? Let's click on that, then tell the computer which one you want to split. So, okay, I want to split this one. So your split line, let's do one. It can be a straight line, can be a curved line, right? As long as it's a line through, right? And you can beyond the edge, not a problem. Which means you can drag this longer, right? So say done. So now you actually have two body. You see that? So if you edit one of them, it will not affect the other one, right? If you drag one of them, it will not affect the other one. See that? So let's change the contour of this one. How are you going to change that? You're going to go to Edit Surface. Now we can change this one. By the way, if you change that one, the subregion sometime could be gone if the change affect that subregion. Then you have to just redraw them, right? Let's see, we're going to place some point, right? And this point, let's do this. Let's put a all right, and you can put a like 5. And we say, okay, we want to change this point to 5, and that 5, all right? So I say done. Okay, no, this one's still there. But you can see you change this, right? So your grass still follow the contour, right? But you can see what we change here doesn't affect the other part at all. Doesn't affect the other part at all. Let's try to merge these two. If you merge, it will affect other part because the transition had to happen from this shape to that shape, right? Let's do a merge surface. Merge surface, this one and this one. See, it changed, right? And also affect our existing subregion is gone, right? It's gone. Right? By doing this, you can see you can pretty much create a lot of interesting, right? Interesting stuff. Right? All right. What about you say, okay, we want to actually build a road, and think about this: two mountains. We have a valley here. What about if I want to build a road, go across, go through the valley, reach the other side, right? Well, if you do not change the contour, you can simply do the subregion yourself. But if you like to change the road contour, you can do a split region by split this one into 3 parts instead of 2 parts, right? Depends on your how you want to do that, right? Let's assume let's just do a split surface again. Right, split surface. So we're going to do here. So let's draw instead of drawing. Well, you can draw a contour if you like to. Okay, or let's draw a straight line, right? We draw that. So okay, say this is going to be our road. Go this way. Probably going to go this way, this way, right? That's our split 1, right? Then we need a, because we want to build a road in the middle, right? We need to do a second split. We pick this one, we say, okay, we're going to split again. This time we're going to use split this surface by picking line, right? Well, we can do a offset maybe. Offset 12 feet. Oh, we couldn't do that, right? Well, that's probably my fault. Okay, let's do this. We first just do escape. Let's just cancel this one, right? Let's. I'm gonna do split face again. I split this one. I'll first trace that. Okay, first trace that existing line with offset 12, right? That's probably a better way. So I'm going to trace that. Offset 12 goes which way? Okay. Probably I should go negative 12. Right, you see I draw this one, that's parallel to the existing line with 12 feet, offset. So then I can say split. Now you can see, now I have a three piece, right? I have this piece, middle piece, this one. So if I assume my middle part is my new terrain, I can edit surface, for example. I simply edit this one. If I assume they're going to be roughly 5 feet all over, pretty much I can do is I can say, okay, this is going to be 5 feet, 5 feet, 5 feet, 5 feet, 5 feet, right? All over. So basically I change the terrain of the road to 5 feet, right? That's actually giving me a more realistic one, right? Oh, here I can maybe lower a little bit more, right? So if this says I want to do that 2 feet somewhere, not 25. So this way you can actually change your grading of your own, right? So this way you can actually make your some of those maybe even lower, right? All right, let's assume you've done this pretty much, so you can simply say okay. Now you can basically you can there's something wrong, right? Yeah, that's fine. So basically you can independently edit this one without affecting the other part, right? Afterward you can say, okay, if I want to continue to merge this one, so I can merge this to this, right? And then I can merge this one to this one, right? All right, I think my road roughly is still there, but it's pretty much gone, right? Maybe you can, afterward, you can do a another subregion, right? A subregion. and go from here to there, right? Let's do a, okay, we do three-phase top surface. Okay, before we do that, let's first do a building path before we do the grid region, right? Let's do a building. Okay, we can do a grid region, right? We can start do the grid region. So in order to do a grid region, you have to tell the computer which one is original, which one is new, right? So let's click on that. Grid region, you're going to say, there are two ways you can say, okay, create a new topography exactly like the existing one. And so both internal and perimeter are copied. Or you say, okay, I just want to do a brand new one, just give me the perimeter part. So I'm going to worry about the other part, right? And I think either way, let's try the first one, right? And so you select this one. All right, basically that's our existing, you can see all the dashed line. That's our existing plan, right? Let's do a new one. All right. Place point. Our new one, okay, we're going to say this is going to be our new contour, right? Then say done. What happened is, right, you can see the dashed line is existing, the solid line is new, right? And some part, you can see this part, the solid line and dashed line are overlap. That means this doesn't really change much. Anything show the different, that means this part's been changed, right? So if you click on the whole thing, right, you probably notice there's a, in a property part, there's a net content field, right? You actually cut what? 10,000 feet, cubic feet, right? You fill actually 500. So your total whole off roughly is what? 9,600 cubic foot, right? So after you make those changes. So where the changes happen, you can see, right? What happened is, those are not happen because pretty much the contour, the same, follow the same, the new one is the same, right? But those part are the one actually, right? You can see the blue part is actually the contour changed, right? Quite a lot. Make sense? That's how you're gonna actually, the computer do their cut and fill, right? So they compare what you did with the original. They got at the cut and fill volume, right? So that's easy to understand, right? Your job, when you want to estimate a cut and fill, and your job is first you're tracing a what? Using the what? Topo surface. You're tracing the existing, right? In our case, for example, I first gonna trace the dashed line here. After I create that topo surface, I edit that one by click on that, use a sub grid region. Then I start tracing my new, right? Then after that done, you say done. You should have a similar like this, right? Okay, let's start to using the building pad part, right? Let's go to site plan. Building pad. All right. So building pad, all right. If I draw something here, as I said, building pad is actually a void, right? It's a void with a solid bottom. So pad 1, how deep you want to go? Let's assume we want to go 10 feet below level 1. I mean negative 10. Right, negative 10, 10 feet below level 1. Right, let's see, done. Where's my building pad? Here it is, right? So my building pad, 10 feet below level 1, right? If you click on that, you can see that's my building pad. See, it's a void, right? It's a void. If you want to see better, maybe I can unshade this one. Just you to hit the mark. Right? And if you see from the bottom, actually I should probably do this. Building pad. Yeah, I want to select my building pad. From here, right? Where's my okay. If you select your building pad, you can see and height offset from level 1. All right. If you select that from level 2, apply, right. Shower, right. So basically, that's a try to actually cut into your terrain, right? Cut into terrain. So without this one, you won't have the big hole, right? You won't have the big hole. All right. That seems not a better view to see that, right? But okay, let's then start to do the. Okay, and let's start to the parking space, right? The parking space you can do is, for example, you can go to your parking component. Then you have all this parking space, right? You can see some of those. If you want to go to the ADA part, you can load family. You go to your site, and go to your parking, the parking space ADA, right? Then you have, if you go to, right, if you go further, for example, parking part, right? You could do parking. I think there's symbol, right? Okay, it's not allowing me to do that. All right, okay. So I probably have to go to site component, no family. Okay, a regular site, regular parking is you have, see, you have this 90-degree parking, like you did this, right? You also have a 60-degree parking like this one, right? You can do so. Parking like that. So that's give you the way to lay out your parking. So you see the host is actually on surface, right? On surface. All right. I think okay, trees, right? There's some trees. We can do that. You could mask assign the site component. You have already a lot of trees, right? Let's put some trees in your building part. All right, 1, 2, 3, 4, 5. So after you create those trees, you go to your 3D view. This tree doesn't look good because you didn't take a realistic view. If you take your realistic view, it actually looks pretty good. All right, and it looks more realistic, right? But also remember they consume a lot of your CPU time, right? You're probably going to slow your computer down. So unless you try to create a final rendering image, so you typically won't use this realistic view, right? But when you create a presentation image, I think that's probably what you should do, right? All right. What's the last one? Last one, yeah, is about property line. So property line is pretty straightforward, right? If you know, you can create by sketching or create by distance bearing. I'll create by sketching. I'll show you what distance bearing looks like, right? So if I create this one by sketching, like say, here's my property line. Done, all right? So if I click on that, you want to see what's the bearing distance looks like. You can see edit table. All right, you can see your distance bearing part, right? Degree, right? North 90 degree, all right? West, all right? And 90 degree toward west. And then you go to the next street, that point, right? You go straight north. You go that one, you go north, another 90 degree, etc. Right? So they are equivalent, right? Of course, you can label your control line if you really want to do, but otherwise you don't have to do that. Right? You really want to label them. Okay. I think that's pretty much we plan to cover today, right on time, and let's stop that.